Close your eyes for a moment. Imagine you're floating high above our world, looking down at Earth, that tiny blue dot, suspended in an ocean of infinite darkness. This is our home. Every person you've ever met, every story ever told, every dream ever dreamed, every tear ever shed, it all happens here, on this fragile sphere we call Earth. But today, we're going to embark on an extraordinary journey. We're going to zoom out, farther and farther from home, until we begin to grasp something almost incomprehensible: the true scale of our universe. It's a journey that will humble us, inspire us, and perhaps change forever how we see our place in the cosmic arena. Our journey begins here, on Earth. But even before we leave our planet's embrace, let's pause to appreciate what we're departing from. Earth is approximately 12,742 kilometers in diameter, a measurement that seems vast until we begin our cosmic voyage. To put this in perspective, if you were to walk around Earth's equator at a steady pace of 5 kilometers per hour, walking 8 hours a day, it would take you nearly 4 months to complete the journey. But we're not walking today. We're ascending, leaving behind the familiar blue skies and white clouds that have sheltered humanity for millennia. As we rise through the atmosphere, we pass through layers that most humans never experience firsthand. At 10 kilometers up, we're at the cruising altitude of commercial aircraft, the edge of where normal life can survive. At 50 kilometers, we've reached the boundary between atmosphere and space itself. The blue sky fades to black, and suddenly, we can see the curve of our world, that gentle arc that reveals Earth's true nature as a planet floating in space. This is the view that astronauts describe as life-changing. The overview effect, they call it, the cognitive shift that comes from seeing Earth as it truly is, a single, unified system without the borders and divisions that seem so important from ground level. But this is just the beginning. We continue outward, and soon, the entire Earth shrinks to the size of a marble, then a pea, then barely visible at all. And ahead of us, growing larger, is our first major destination, the Moon. To the Moon and beyond. The Moon sits approximately 400 kilometers from Earth, a distance so vast that it challenges our earthbound intuition. To truly understand this scale, let's imagine some comparisons that bring this cosmic distance down to human terms. If you could drive to the Moon in a car traveling at a constant 100 kilometers per hour, never stopping for food, fuel, or sleep, your journey would take you 160 days. That's more than 5 months of continuous driving. If you took a more realistic approach, driving 8 hours a day, your lunar road trip would stretch for nearly a year and a half. Or consider this: you could fit all the other planets in our solar system: Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune, in the space between Earth and the Moon, with room to spare. This gap that appears as just a small step in space photographs is actually an enormous gulf. But perhaps the most profound way to understand this distance is to consider light itself. Light, traveling at 300 kilometers per second, the fastest thing in the universe, takes 1.3 seconds to travel from Earth to the Moon. When Neil Armstrong first spoke from the lunar surface, his words took over a second to reach Earth. In the conversation between Mission Control and the Apollo astronauts, every question and answer was separated by nearly 3 seconds of absolute silence, the time it takes for human voices to cross the void between worlds. From the Moon's surface, Earth appears as a blue and white marble hanging in the black sky. Beautiful, distant, and impossibly fragile. The astronauts of Apollo 8, seeing Earth rise above the lunar horizon, described it as the most beautiful sight they had ever witnessed. This image, Earthrise, became one of the most influential photographs in human history, showing us our planet as it truly is, a living oasis in an ocean of emptiness. But the Moon is just our first stop. To continue our journey toward understanding cosmic scale, we must leave even this lunar vantage point behind and venture toward the heart of our solar system, the Sun. Racing toward the Sun. The Sun lies approximately 150 million kilometers from Earth, a distance so fundamental to astronomy that we've made it our standard unit of measurement for the solar system. We call this distance 1 astronomical unit, or AU. It's our cosmic yardstick, the ruler by which we measure the vastness of space. But what does 150 million kilometers really mean? Let's explore this distance through different perspectives, each one revealing another layer of the Sun's incredible remoteness. Light from the Sun, racing through the vacuum of space at its maximum possible speed, takes 8 minutes and 20 seconds to reach Earth. This means that when you step outside on a sunny day, you're feeling the warmth of sunlight that left the Sun's surface more than 8 minutes ago. You're literally basking in the past. The Sun you see is the Sun as it was, not as it is at this very moment. This creates a strange and wonderful reality. If the Sun were to suddenly vanish, which thankfully it won't for another 5 billion years, we would continue to see it shining in our sky for 8 minutes and 20 seconds. We would have no idea that our star was gone until that final ray of light completed its 8-minute journey across space. Now, imagine attempting this journey not at the speed of light, but at speeds more familiar to human experience. A commercial airliner cruising at 900 kilometers per hour would need 19 years of continuous flight to reach the Sun. If you could walk there at a steady pace of 5 kilometers per hour, 8 hours a day, your journey would take over 10 years, longer than all of recorded human civilization. The Sun itself is a giant beyond comprehension. Its diameter is 109 times that of Earth, meaning you could line up 109 Earths across the Sun's face. Its volume is so vast that it could contain 1.3 million Earths. Every second, the Sun converts 600 million tons of hydrogen into helium, releasing more energy than all the nuclear weapons ever built on Earth would produce if detonated simultaneously every single second for millions of years. And yet, from Earth, this cosmic furnace appears as merely a bright disk in the sky, no larger than the moon to our eyes. A perfect example of how distance shapes our perception of scale in the universe. The red planets dance. Our next destination takes us beyond the familiar warmth of our Sun's nearby embrace to Mars, the red planet that has captured human imagination for centuries. But Mars presents us with a unique challenge in understanding cosmic distance, because unlike the Moon or Sun, Mars doesn't maintain a constant distance from Earth. Mars orbits the Sun just as Earth does, but in a larger, slower orbit. This cosmic dance means that sometimes Mars is relatively close to us, and sometimes it's on the completely opposite side of the Sun. At its closest approach, called opposition, Mars is about 54.6 million kilometers from Earth. But when it's at its farthest, at conjunction, when Mars is on the opposite side of the Sun, this distance stretches to 401 million kilometers. To understand these distances, let's return to our familiar comparisons. At its closest, Mars is still 142 times farther from Earth than the Moon. If you could drive to Mars in that same car traveling 100 kilometers per hour, your journey would take between 2 and 18 years, depending on where Mars happened to be in its orbit when you departed. Light from Mars, when the planet is closest to us, takes about 3 minutes to reach Earth. When Mars is farthest away, that light travel time stretches to 22 minutes. This means that when NASA's mission controllers on Earth send commands to rovers on Mars, they must wait anywhere from 6 to 44 minutes for a round-trip communication, 3 to 22 minutes for the signal to reach Mars, and another 3 to 22 minutes for the response to come back. This vast distance and its constant change makes Mars exploration one of humanity's greatest technological challenges. Every mission to Mars must be planned years in advance, calculating not just where Mars is now, but where it will be when the spacecraft arrives. The journey takes between 6 and 9 months, and there's no turning back once you've committed to the trajectory. Consider the remarkable fact that we have successfully landed multiple rovers on Mars' surface. These robots, Spirit, Opportunity, Curiosity, Perseverance, are the most remote explorers in human history. They operate millions of kilometers from their home, receiving instructions that are minutes or tens of minutes old, working essentially alone in an alien environment. When they discover something extraordinary, a sign of ancient water, an unusual rock formation, perhaps even evidence of past life, we don't learn about it until their signals cross the vast emptiness between worlds. Yet these mechanical ambassadors of human curiosity continue their work day after day, extending our senses across the solar system and showing us that even the most vast distances cannot constrain human exploration and discovery. To the edge of worlds, as we continue our outward journey, we encounter distances that begin to strain even our expanded understanding of scale. Our destination now is Neptune, the outermost major planet in our solar system, lying roughly 4.5 billion kilometers from Earth. To put this distance in perspective, if Earth's orbit around the Sun is a circle with a radius of 1 step, Neptune's orbit would be a circle with a radius of 30 steps. Neptune is 30 times farther from the Sun than we are, dwelling in a region of space so cold and distant that it challenges our ability to even imagine the environment there. Light from the Sun takes 4 hours and 15 minutes to reach Neptune. This means that when you see the Sun at noon, Neptune is experiencing the Sun as it was at 8 in the morning. Neptune exists in humanity's past. In terms of sunlight, the warmth and energy that powers life on Earth becomes, by the time it reaches Neptune, a faint whisper, providing only 1/900th of the energy per square meter that Earth receives. A spacecraft traveling from Earth to Neptune at the speed of our fastest current technology would take 12 to 15 years to complete the journey. In human terms, a child born when the mission launched would be in high school by the time the spacecraft arrived. Only one human spacecraft has ever visited Neptune. Voyager 2, launched in 1977, reached the ice giant in 1989 after a 12-year journey that took advantage of a rare planetary alignment that occurs only once every 175 years. The images Voyager 2 sent back, taking 4 hours to travel from Neptune to Earth at the speed of light, revealed a dynamic, beautiful world with winds reaching 100 kilometers per hour, the fastest in the solar system. Neptune represents the edge of our traditional solar system, the boundary of the major planets. But it's not the end of our Sun's influence, nor is it the end of our journey into scale. Because from here, we must consider an even more distant traveler, one that carries with it a message from humanity itself. The pale blue dot, launched in 1977, the same year as its twin Voyager 2. Voyager 1 was designed to explore the outer planets of our solar system, but its mission evolved into something far more profound. It became humanity's most distant ambassador, carrying our voices, our music, our hopes into the infinite ocean of space. As of today, Voyager 1 has traveled for more than 4 decades, covering a staggering distance of over 22 billion kilometers from Earth. To understand this distance, consider that it's nearly 150 times farther from Earth than we are from the Sun. If the Sun were a basketball sitting in the center of a football field, Voyager 1 would be more than 20 kilometers away, far beyond the horizon, in another city. But Voyager 1's greatest contribution to human understanding didn't come from its distance, but from looking back. In 1990, at the suggestion of the renowned astronomer Carl Sagan, NASA commanded Voyager 1 to turn its camera back toward home for one final photograph. From a distance of 6 billion kilometers, 40 times farther from the Sun than we are, Voyager 1 captured what became known as the pale blue dot photograph. In this image, Earth appears as a tiny speck, smaller than a pixel, suspended in a beam of scattered sunlight. Carl Sagan, reflecting on this image, wrote words that have become among the most profound ever spoken about our place in the universe. Look again at that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines. Every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust suspended in a sunbeam. This image, this perspective, fundamentally changed how we see ourselves. All of human history, every war ever fought, every discovery ever made, every love story ever lived, it all happened on that pale blue dot, barely visible in the cosmic dark, beyond the solar system. But even Voyager 1, humanity's most distant creation, has barely begun to show us the true scale of space. Our solar system, vast as it is, represents only the tiniest fraction of our cosmic neighborhood. The nearest star to our Sun is Proxima Centauri, part of the Alpha Centauri system, lying 4.24 light-years away. A light-year, the distance light travels in 1 year, is approximately 9.46 trillion kilometers. Proxima Centauri is about 268 times farther from us than the Sun. The journey continues. The distances we've explored today, from Earth to Moon, from Sun to Neptune, from our solar system to the edge of the observable universe, they continue to expand. Space itself is growing, carrying galaxies away from each other at ever-increasing speeds. The universe is not static. It is dynamic, evolving, expanding into futures we can barely imagine. And somewhere in all of this vastness, on a small blue world orbiting an ordinary star, beings made of stardust continue to look up at the night sky and wonder. They launch spacecraft toward distant worlds. They point telescopes toward ancient light. They ask questions about their place in the cosmic arena. The universe is big, bigger than we can truly comprehend. But it is not bigger than our capacity to wonder, to explore, to dream, and to discover. In the end, perhaps that is what makes us significant in the cosmic scale. Not our size, but our curiosity. Not our physical presence, but our endless desire to understand our place in the magnificent, humbling, inspiring vastness of space. The journey continues, the questions multiply, the wonder grows, and somewhere in the darkness between the stars, Voyager 1 continues its lonely voyage, carrying humanity's message into the infinite. A small reminder that on one tiny world, in one small solar system, in one ordinary galaxy, something extraordinary happened. The universe became aware of itself. The universe is vast. We are small. We are home.